Before we start the next lesson, I just wanted to do a quick recap of what we've done in this unit so far and then where we'll be going, what we have remaining. So we're on a unit called Relations and Functions, and in your workbook, it's broken down into two chapters. So the first chapter, Relations and Functions, this is what we've already done. So we learned about ordered pairs. So ordered pairs, remember, fit on our Cartesian plane, and it's always x comma y. Then we learned about x and y intercepts. So for example, if I gave you an equation and I said, what's the x-intercept? What you would always do is you let y equal 0. And if I said, conversely, well, what's the y-intercept of a given equation? You would let x equal 0, and then you would solve for y. We did domain and range. And then we ended off with something called functions and function notation. And remember that a graph is a function if it passes the vertical line test, right? So I'll give you an example. If I said, is this graph here a function? The answer would be yes, because no matter where I draw a vertical line, it would pass the vertical line test. If I gave you a graph that looked like this, and I said, is that a function? You would say no. That's not a function. It fails a vertical line test because a vertical line cuts through my graph at two separate points. This graph here would be considered a relation. This graph is a relation and a function. What we're moving on to now is we've got 3 more lessons in this unit, and we're moving on to something, the chapter called Characteristics of Linear Functions. So first of all, from here on out, everything we're going to be dealing with, it's going to be a function. So it will pass that vertical line test. The second thing that we're going to be dealing with is, remember that this word linear has line in it. So all of our graphs are going to be what we call line graphs. Okay, so they're going to be straight lines and they will all be functions. They will all pass the vertical line test. There's going to be 3 lessons. So this lesson is going to be on slope, which is page 519 in your workbook. And then we'll do the slope formula. And last, we'll look at parallel and perpendicular lines. Okay, so this is sort of what's remaining in the unit. Okay, so for the first lesson on characteristics of linear functions, we're going to be doing lesson 4 in your workbook, and it's on page 519. So what this lesson is on, it is on calculating the slope of a line. So I'm going to be giving you various lines, and you're going to be exclusively calculating the slope. There is a formula for slope. Actually, there's 2 different formulas. And this lesson, I'm going to be using this formula here. So slope is equal to rise over run. And in the next lesson, I'll be giving you a second formula for slope. Now, when I talk about slope, so this is a line segment here. When I refer to the word slope, what I'm talking about is the steepness of the line. So this line segment here would have one particular slope. If I change the line segment and make it steeper, it would have a different slope. Okay, so slope is just the steepness of the line. This line here is like walking on the ground. If I said, well, what's the slope of the ground? Does the ground have an incline? The answer is no. The slope of this line would be 0. Okay, so a flat ground doesn't have any incline to it. The slope is 0. What you're going to be able to do after this lesson is you'll be able to look at lines either going up like this or down like this, and you'll be able to tell me if it's got a positive or negative slope. So when a line is going up to the right, I will often say, okay, you're climbing up a mountain, and this is going to have a positive slope. And this one, it's like you're sliding down a hill. This is going to have a negative slope. And then again, if you have a completely horizontal line, it is going to have no slope. Okay? So what we're going to do is class example 1, and it says each line segment on the grid has endpoints with integer coordinates. Complete the table below. Okay, so line segment AB. So what I'm going to do is I'm going to put the endpoints on. So there's an endpoint and here's an endpoint. And remember that in order to calculate the slope, So the slope, and then I'm going to say what line segment I'm calculating, which is AB. The formula for slope is rise over run. So what I need to do is I need to figure out, going from point A to point B, how much am I going to rise and how much am I going to run? So I'll show you what I mean. I'm going to start at point A, and I'm going to rise 1, 2, nope, I'm only going to rise 2. Let me get rid of that. From point A, 1, 2, I rise 2, and I need to run 1, 2, 3, 4, 5, 6, 7. So the slope of line segment AB is 2 over 7. Okay? Now, CD or DC. Okay, so this one here, let's put our let's put our endpoints on. So from here to here, what do you have to rise and what do you have to run? Okay, so I'm going to start at D. So I'm calculating the slope of this line, and I'll show you how after we could actually start at C if you really want. But if I start at D and I said, okay, what's the rise? 1, 2, 3, 4, 5. And I need to run 1, 2, 3, 4. So my slope is rise over run, which is 5 over 4. Okay? Now, remember that I said if your line is in this orientation, that's going to be a positive slope. And if you look, both AB and CD, these were both positive slopes. That's a positive number, and this is a positive number. This slope here is like sliding down the hill. This is going to be a negative number. So let's see, how do we get a negative number from EF? Okay. And here's how we do this. Okay, so I'll put in my 2 line segments. Now again, I could start at point E or I could start at point F. I'm actually going to start over here at I'll start at point E. Now I'm not rising, right? In order to get to F, I actually have to fall. So how much do I have to fall? 1, 2, 3, 4, 5. And when you fall 5, a fall is a negative move. Okay, so I gotta put negative there. And then I have to run 1, 2, 3. So my slope is negative 5 over 3. So I just want to recap the moves that you make. And here are the moves. If you move up, that's a positive move. If you move down, that's a negative move. So for the rise, we could either go up or down, right? If you count up, that's positive. If you count down, that's negative. For the run, you could either go left or right, right? If you run right, as I did in all of these 3 examples, that's going to be a positive move. If you run left, that's going to be a negative move. Okay, so I'll show you what I mean. I want to do one more example from this, and I'm going to start at the opposite point of where I did before. So remember AB. So if I go back to AB, watch what would happen. So A, B. I'm going to now start at B and get to A. So from B, I have to do a fall, right? So I'd say, okay, I'm going to fall 1, 2. And remember that a fall is negative. Then say from here, am I going left or am I going right? And I'm going to be counting left. 1, 2, 3, 4, 5, 6, 7. And what was a left move? Was a left move positive or negative? A left move was negative, so that would be negative 7. So my slope would be rise, which was negative 2, over the run, which is negative 7. 2 negatives will actually cancel out to give you a slope of 2 over 7, right? Which is this slope here. So what I again want you to see is it doesn't matter which point you start at to count, as long as a fall is negative. If I started at F, a rise would be positive. A left move is negative, but a right move is positive. Okay, so if I went from C, this would be a down, which would be negative, and left, which would be negative. We'll do several examples of these and you'll get the hang of it. Okay, what investigation one, actually, no, we're going to skip investigation one. Let's go to investigation 2, and I just want to show you something for this investigation. This is a completely horizontal line, and if I said, what's the slope of the completely horizontal line? There is no incline if you have a horizontal line, so the slope is 0. If I said, well, like, how would you show that? You would say, okay, the slope is equal to the rise over the run. If I was calculating the slope of, let's say, EF, what is the rise? There is no rise, right? So the slope would be 0, and the run would be 1, 2, 3, 4, 5. And 0 divided by 5, if you type that in on your calculator, would be 0. So all of the slopes in grid 1 have a slope of 0. Now, grid 2 is interesting. So what's the slope of a completely vertical line? If I gave you this, that's going to have a positive slope. If your line segment was in this orientation, that's going to have a negative slope. If I gave you a horizontal line, and I said, what's the slope of that? That would be 0. And then if I gave you a completely vertical line, like a cliff, and I said, well, what's the slope of a cliff? This essentially is what is referred to as undefined. And I will show you why. Let's look at this line segment here. So slope is equal to rise over run. From I or J to I have to rise 1, 2, 3, 4, 5, 6, 7. 7, and I'm running 0, right? I'm not making a left or a right move. If you type in on your calculator 7 divided by 0, that is undefined. So if you see a horizontal line, you tell me that the slope is 0. If you see a vertical line, you say it is undefined. So all of the slopes in grid 2 are undefined. Complete the following statements. Horizontal lines, so this is a horizontal line, have a slope of 0. Vertical lines, there's your vertical line, has vertical line segments have an undefined slope. Okay, investigation 3, what I'll do is I will do one slope from each grid, and then I'll get you to pause it, and then you'll do the remaining slopes. What I want you to see, if you were in class, I'd say, okay, you guys, all 3 of these slopes, are they going to be positive or negative? So all of these are climbing up a mountain or going up a hill. So these would all be positive. These ones, it's like you're sliding down a hill. These would all be negative, right? So grid 1, I'm hoping that we calculate everything's going to be positive. Grid 2, they have to be negative. Now, I can't use the endpoints here, right? Because they're not good endpoints. You have to pick points on your line that have coordinates that you could clearly see. So for example, I could pick that point and this point, right? This is another point I could pick. And all you need is 2 points in order to be able to calculate the slope. So I'll show you, like there's different ways that you could do this. So if I was calculating the slope from this point to this point, watch what would happen. My slope is rise 1, 2, 3, 4. And my run is 1, 2, 3, 4, 5, 6. Okay, So 4 over 6 is my slope, but we always have to reduce it. So 4 over 6, if you type that in on your calculator, and then if you did math one fraction, that's going to reduce to 2/3. Okay? And I'll show you. So the actual answer is the slope is 2/3. Now, watch what I could do. I'm going to erase this, and I'm going to calculate the slope from now this point to this point. Rise of 1, 2, and a run of 1, 2, 3. And I get that exact same slope of 2/3. So what I need you to see is that this line, the entire line, has a slope of 2/3, right? From here, I could rise 1, 2, run 1, 2, 3, and there's my point. If I said, well, where would the next point on this line be? Rise 2, run 1, 2, 3. The next point on this line would actually be right there, because the slope of this line is 2/3. Okay, so what I'll do is I'll give you coordinates for line 2 and 3. So for example, that's a good point, and that's a good point, right? So figure out your rise and your run. And for line 3, that's a good point, and that's a good point. So pause the video, calculate the slope of line 2 and 3, and then I'll give you that right away. Okay, line 2, if you did it correctly, you should have gotten a slope of 5 over 2. And line 3, if you did it correctly, would have a slope of 1 over 3. Rise of 1, run of 3. I will do one example here, and then I'll get you to pause it and do the other examples. So again, we need to find good points. So if I was to do line segment 4, I'm going to go, that's a good point, and this is a good point. Now, I am falling 2, and a fall is a negative move, and then I'm running 3, and that's a positive move. So negative 2/3. I could have gone the opposite. I could have started here and said I'm going to rise 2. A rise is a positive move, and then run 3. But because I'm going left, that would be a negative move, and that would still give me 2 over negative 3, which is the exact same thing as this, right? So I could have written it as negative 2 over 3, or 2 over negative 3, or I could put the negative in front and then just say 2/3. That's the slope of this line. Okay, for line 5, there is a good coordinate. So we want coordinates on what's called the crosshairs, right? And that would be a good coordinate. And for line 6, the only points I could use are that guy and this guy. So pause your video, figure out, see if you could get the slope of line 5 and the slope of line 6, and then I'll give you that answer. Okay, so the slope of line 5, if you did it correctly, is negative 5 over 2, and the slope of line 6 is negative 1 over 3. What I recommend is I recommend pausing this video at this step here, or this stage, and doing questions 1 and 2 in your homework, which is just exactly what we did, calculating the slope, okay? And then when you're done, unpause this and we'll finish off the last 2 class examples. Okay, if you finished off those 2 questions for homework, question 1 and question 2, we have 2 class examples left, and then I'll assign you some more questions. We're not going to do class example 2, so you can cross that out. We're going to do class example 3. Okay, draw a line segment on the grid which passes through this point here. So this point, negative 4 comma 2, remember that's what we call an ordered pair, and that ordered pair is at the x value is at negative 4, so minus 1, 2, 3, 4, and the y value is at 2. So that ordered pair is right there. Okay, I'm going to erase this. Then what it says is this, from this ordered pair, we're going to draw a line that has a slope of -2/3. So let's write that down. Slope is equal to -2/3. Now remember that slope is rise over run. And what was a move that's negative? That is not a rise, that is a fall. So we're going to fall 2, and then I'm going to move to the right 3. So from this point here, I'm going to fall 2, 1, 2, and I'm going to move to the right 3. 1, 2, 3, and there is my next point. From here, I'm going to fall 2 and go to the right. 1, 2, 3. There is my next point. Again, fall 2 and go to the right 3. There's my next point. Get yourself a ruler. If you did this correctly, this is a linear graph. Remember, a linear function, which means it's a straight line. All of the points should lie exactly on your graph, so no points should essentially, what we say, jump off the graph. And then you draw an arrowhead at each end to show that this line could continue forever. And that would be your solution. Now, one thing I want to show you, I started at this point and I kind of went down the line like this, right? Oh, and looking at this line, if I said, is this a positive slope, negative slope, what would the slope be? We know that we're going down the hill, so this is a negative slope, and sure enough, it was negative, right? How would you go, though, from this point to the next point? So instead of falling 2 and running to the right 3, you would go the opposite. So if I said, well, what's the opposite of falling 2? You would say rise 2. And then what's the opposite of going to the right 3? It'd be going to the left 3. And there would be my next point. Okay? Class example number 4. A slope has a line segment of -5/4, and it has a rise of 12. Calculate the run as an exact value. So for this question here, the only formula that we have is this guy. Slope is equal to the rise over the run. So they've said that the slope is -5/7. So I'm going to take that slope out and I'm going to put in -5/7. So essentially, you guys, what that is a fall of 5 and a run of to the right 7, right? That's what the slope is. Then it says, okay, using this formula, they want the rise to be 12. So let's take this out and put 12 in. And what would the run be? Calculate the run. Okay, so they want that. So essentially what this becomes is -5/7 is equal to 12/x. If I said, well, calculate what x is, you would need to cross multiply. So this times this would be -5x. And 7 times 12 would give me 84. And then we need to get x by itself, so get rid of that -5 by dividing both sides by -5. And x is equal to, as an exact value means no decimals, so x is equal to 84 over -5. And x, remember, was the run. So the run is -84/5. And just to sort of double check, here's my check. We know that the slope is equal to the rise over the run. The rise, they said, was 12. And the run happens to be a fraction, but that's fine. -84/5. If I type this into my calculator to figure out, well, what's the slope if I have a rise of 12 and if that is my run, let's check what we would get. So on our calculators, 12 divided by open bracket, negative 84 divided by 5, math 1 fraction, and there's my slope, negative 5 over 7, which is a down move of 5 and a right move of 7, and that's what they had originally given me. My slope is negative 5 over 7. So this would just be like an algebra question. Your remaining homework, and I'll do 2 questions with you, 1 to 3, 4, A, B, and C, 7, and 9. Okay, so you should have done 1 and 2 already. And now I need you to circle question 3. So remember question 3, that's your ordered pair. So at negative 5, x is negative 5 and y is negative 2. There's your point. And then this is your slope. So slope is equal to 2/3. Remember that slope is rise over run. So from this point, you're going to rise 2 and you're going to run 3. And that would be your next point, right? So figure out a couple of those, a couple more points, and then get your graph. This is the exact same thing that we just did. So find this point here, x is 2 and y is 1, would be right there. And then you're going to do a slope of 2/5. So you're going to rise 2 and you're going to run 5. So up 2 and run 1, 2, 3, 4, 5. Okay, and again, I can't go up 2 and run 5 because I'd be off the grid. So now what I'll do is I'll go to this point and I'm going to do the opposite. So instead of rising 2, the opposite of rising 2 is falling 2. And instead of going to the right 5, I'm now going to go to the left 5. 2, 3, 4, 5. So that first equation, there it is. Okay. For this guy here, put a dot at put your ordered pair at 6, negative 3, and then slope of negative 1/3. Remember that you could either do this, or that is the exact same as moving the negative down here. So you could either do a fall of 1 and to the right 3, or rise of 1 and to the left 3. So just realize that these two are the exact same number. I'm just putting that negative either with the 1 or with the 3. But if you type these in your calculator, you get the exact same negative 0.333. And try C. The other question that I want you to do is find the slope of line segment PQ. So again, how would we do that? Slope is equal to the rise over the run. You only need 2 ordered pairs in order to get your slope. So if I was to start at P, and if I was to say, okay, well, what's the fall that I need to do to get to Q? Well, if I'm at 4 and I'm going down to 0, I'm going to fall 4, right? So this would be falling 4. And then how much are you running if you're going from 0 to 3? You're running 3. So negative 4/3 would be your slope of that line. And then the last question, oops, I believe was 7. A ramp which has been set up by skateboarders has a slope of this. Okay, so this is a positive slope. So the slope of this is 2/3. Right? That's the equation for my slope. And what it says is the ramp has a base length of 1.5 meters. So what I'm hoping you could see is that this could make a triangle. And this is 1.5 meters. The ramp has a base length of 1.5 meters. Calculate the height of the ramp. Okay? So we know that slope is equal to rise over run. They told me that the slope is 2/3. The rise of this would be x, right? This is my slope, and the slope is made at, this would be the run, and this would be the rise. So it would be the rise, which is x, over the run, which is 1.5. And then from here, you would solve for x by cross multiplying. So this times this would give you 3x is equal to 2 times 1.5, right? So 2 times 1.5 is 3. Isolate x by dividing both sides by 3. And x, which is equal to the rise, is equal to 3 divided by 3, which is 1. So this is 1. And I want to double check my work. I know that slope is equal to the rise over the run. Now I know that this is my rise. This is my run. And let's see if on my calculator, when I type in 1 divided by 1.5, if I get the slope of 2/3. So 1 divided by 1.5, math 1 fraction, gives me a slope of 2/3. So I did it correctly, and my answer is a rise of 1.